Alright, we're taking an evening walk at Penitentiary Glenn, right down the street from Holden. The reason is I really felt like there was more that I wanted to say about time and clocks. It was actually an interesting discussion, and I think it's important to understand this and to go into this because time is sort of at the root of everything. And we use that word sometimes without even knowing what it means. And I want to start with something really basic, which is, what is a clock? Well, how do we know time exists? Let's just start with that. What is time? And one way of looking at it, you could say time is what a clock measures. Right? A very simple way. And then you have to ask, what is a clock? Well, a clock is just a device. You could say, I'm a clock, you're a clock, the earth is a clock, the sun is a clock. This is sort of the point that I wanted to get to. This is maybe a little more on the physics side, but it's important to understand because sometimes we take time for granted because we have a device like a phone or a clock on the wall that has a swinging pendulum or whatever it is, and that measures time, right? And we see that clock moving and changing, and so we think time exists because we see clocks changing. What if that clock didn't change? When your clock runs out of battery, does that mean time has stopped? And we say, oh, well, that's silly. But if time is what a clock measures and that clock isn't functioning, then is time passing for that clock? You know, you really have to go into this because maybe this is the most important thing to go into, because everything revolves around this idea we have of time being some absolute thing. And even since I was a kid, I don't know if I ever really fully understood time. And I think you can understand it if you think of it in terms of states, changing states. Not time as some universal thing that is always passing, right? And we know that's not true, even from physics. I mentioned this in the last general relativity, special relativity. But let's not think of this in complicated mathematical terms. You don't have to. You can just think of this in terms of the clocks that everyone has in their home or in your pocket, your cell phone, or your body. People talk about my biological clock is ticking. That's actually very accurate because the body is a clock in a way. And age, what is age? Some people age rapidly and some people age slowly. You know, you may have an 80-year-old that jogs 10 miles a day and in some sense has the body of like a 30-year-old. And you can have a 30-year-old who maybe doesn't treat their body very well. Maybe they've smoked and used drugs and don't exercise and, you know, all the things that wear the body down. Because the body is a machine that needs to be kept running, right? That there's a certain operating manual. You know, it's not written down, but like you can abuse the body and cause it to disintegrate faster. And if you take care of the body, you can cause it to last longer. So age is how we look at biological time, but age is a very subjective thing. Age by number, again, where does that number come from? It comes from a clock or from the motion of the planets. Like, we have day and night because the earth is spinning, right? And so there's a clock. It's a cycle. So clocks are about cycles, counting. Even the most accurate clocks we have are atomic clocks. How do they work? They work because you have a cesium atom. Well, let's just say the cesium atomic clock. There's probably many varieties, but this is the one I'm familiar with. The classic atomic clock that vibrates at a particular frequency when resonant, when it's sort of charged with by I'm no atomic clock expert either. But if you bombard, say, a cluster of cesium atoms, and this is the thing, at what temperature, like there's so many variables even to this atomic clock. Like there's a precise definition for what a second is in terms of the vibrations of these cesium atoms, unless they've changed it. The place to go to check this is NIST, the National Institute of Standards and Technologies, right? Has a definition of the second, and it requires you building essentially an atomic clock and then measuring the vibrations of the cesium atoms, which it vibrates very rapidly and at a very particular frequency. And what that means is it's like a pendulum, like in the old-fashioned clocks, a pendulum swings back and forth, and every time the pendulum swings, the big hand and little hand on the clock move one tiny notch, right? So the pendulum, it's a repeating cycle that repeats, and causes the hands on the clock to move, the state of that clock to change, right? With every pendulum swing. That's how mechanical clocks work. So mechanical clocks, there's a state in the clock which could be thought of as the angle of the hands, right? That every time the pendulum swings, and it's swinging because of, say, gravity, right? The old-fashioned grandfather clocks or whatever, you have little weights that are providing the energy to move that pendulum. And then when the pendulum swings at a regular rate, and again, that's at a regular rate, you have to put that in quotes. If gravity were different, that pendulum would swing at a different rate, and it would measure time differently. At a different, time would pass faster or slower. And we might say, well, that's a broken clock. But what this really comes down to is there is no way to define absolute time. Time can only ever be defined in terms of the state of something we've designated as a clock. And we try to come up with a mechanism for causing that clock, for the state of that clock to change in a regular, repeatable way, so we can count the number of changes of that clock, and that becomes our measurement of time. And then we say, okay, that's our standard of time. And now everything else we can measure with respect to that standard. It always kind of drove me crazy, though, because even with NIST, like, setting the standards, it's like, so if you define a second in some slightly different way, you would get, and we have in the past, you get a different second, different increments of time. And then, but the people still have in their mind, well, yeah, but there's still this absolute time, right? Time is still progressing. We like to think this. And this is what I'm getting at is that we have faith in some sense that there is this universal absolute time, even though it's been sort of disproven. This is what's kind of strange too, right? Relativity has shown there is really no such thing. There's no absolute time. And if you can't measure time, then what is time? Is there time if you can't measure it? This is so important, because just look at a rock. A rock has no sense of time, right? Or not the same as our sense of time. Like, what's time to a rock? What's time to a mountain? That doesn't change. Like, its internal states. Think of a rock as having a certain number of states. It is changing slightly over time, but very slowly. Like, nothing much is changing. You look at a rock today, you look at that same rock tomorrow, it's pretty much the same rock. Hasn't changed much, right? So you can think of time also as the state changing, right? If the state doesn't change, so if a rock stays pretty much a rock today, tomorrow, next week, the rock isn't really aging. And we would say time isn't really passing for that rock. Like, we like to think that, well, time's still passing for that rock, just slowly, right? But in some sense, if no state changes, there is no time. And this is another thing to think of, like, and we talked about this in an earlier video. Think of an electron or a photon. the smallest subatomic particles. We say an electron is an electron always. It has a certain charge. It has a certain mass that never changes. The mass of an electron never changes. The charge of an electron never changes. Every time we observe an electron, it has the same mass, same charge. Is that electron aging? And no. There's no time. For that electron, there is no time because there's no change in its state. It has sort of a state that stays the same. And if the state of something stays the same, you could say there's no passage of time. There's no change in state. When the state changes, the pendulum is swinging back and forth, the cesium atom is oscillating, the phone we have that's measuring time, I mean, there's all kinds of stuff going on there, right? The battery and the entire operating system, and there's all these, very complex state changes that are occurring within your phone, but it's still ticking the seconds away, right? There's a clock built into your phone. And, even how you perceive the passage of time. So when you're awake, like right now I'm walking through the forest, I'm seeing things pass by me, and I have some sense of time passing because I'm seeing things and I'm aware. I'm aware of changes. If I was unconscious, or even when I'm sleeping, I don't experience time that way. I may not experience any time. I may go to sleep, wake up 9 hours later and say, where did the time go? Right? I have no experience, no memory of time. So did time pass for me? And we like to think, well, it's still passing even though we don't see it. But that's, how would you know any sense of time? And the only reason you know that time has passed is you wake up, you look at your clock, which is the device you have next to you that measures time, and it has a different number on it than it did before. So the state of that clock has changed. And then in your mind you have a concept that is the passage of time. You say, okay, so I was asleep for 5 hours because the clock next to me tells me this. But that clock is just a device measuring its own internal states. And as we talked about before, there's sort of a synchronization, or we'd like to say there is, or that's, it's an assumption. It may not be that way. It could change. But we think there's a synchronization between my states as a human being and the states of that clock. So if the clock says 5 hours that I've slept, and I say this body has slept for 5 hours, and I have this sense then of there being a universal time. But here's, this is another thing. Temperature affects the rate at which processes occur. So some animals hibernate, right? Or some animals, when they get cold, their biological processes can almost stop. And it's almost like their internal clock stops, because temperature is a measure of energy. Energy is a measure of motion, right? And so if let's say the atoms in your body just weren't moving anymore, then there would be no passage of time. You would remain in that state. Your time isn't passing. Right? If you were just frozen to absolute zero right now, so there was no energy, nothing is changing, everything was frozen in your current state for some reason, and there was no energy to change states, then time would be frozen for you. In the sense that the states of your body would stop changing. So it's only because the states of our body are changing that we experience age, or even consciousness. Like now I'm aware of I'm walking through the woods and I'm hearing booms in the distance, and I'm hearing a stream down below me, and I'm seeing trees pass me, and all of that gives me a sense of the passage of time. But all that is tied to my senses. What if I sensed nothing? What if I didn't see anything, hear anything, feel anything, taste anything? And what would time be like then? What would, how would I even know that there's time occurring? We could say, well, there's thoughts, which is true. The brain is itself a clock, and we talked about this too. Thinking is a material process that is occurring, just like every other process. The state of your brain is changing. And we can regard those state changes as thinking. That the brain is undergoing a series of changes, and the thoughts that are, one thought, next thought, that is occurring is what we can refer to as thinking. And if that were to stop, then there would be no passage of time. Like there would be no sense of time at all. Right? No senses, no thoughts, no passage of time. The ending of time. And we've talked about the ending of time and its importance, and the ending of thought, and we've said thought is time. Thought is our perception of time, right? If there was an end of thinking, there would be an end of time as we experience it, in the same sense that a rock that has no thoughts doesn't experience the passage of time in that way. You know, there's a geological time scale where things change, of course. You know, the mountains form, and I mean glaciers come and go. There's different time scales where things are occurring over those time scales, which is also interesting, right? Because it means time on a geological time can be different than our biological time, different from clock time. So once you start really saying, okay, so time is not constant, then relativity, all that stuff doesn't seem so strange anymore, right? Because it's like, we can't even measure time properly, or we can't even come up with a clock. We try our best to come up with a standard for measuring time, but that has changed over time, and it no doubt will change in the future, and it's arbitrary. Somebody just comes up with an arbitrary definition of what time is. That is not absolute time. It's still relative time, that somebody has to define what that means, and then everything's just like a ruler, right? How would we measure length? If you have a ruler, you can measure length, but if you don't have a ruler, how do you measure anything? So that ruler becomes your measuring stick, literally your measuring stick, that you measure all of the lengths by, and say, well, this thing is 3 feet because it's 3 rulers long, right? If I put 3 rulers back to back, and that's how long the thing is. Now, so it's always comparing, it's relative. So the length of something is only meaningful, I can only measure it with respect to something else, a ruler. All measurement is relative. It's not absolute. Measurement of length, time, weight. You have to have a standard. Oh, the deer took off in the woods. Not real scared of me, I don't think. So, you know, this is the kind of thinking, right, that people do. You know, Einstein himself thought about light and time, the speed of light, and he had a lot of thought experiments. Gedanken. I think they were called Gedanken, from the German word. A thought experiment. And thinking, though, still is limited, right? It's our human brain. But this is how we figure things out sometimes, is through a process of inquiry, where we don't just accept what everyone considers to be true. We examine it for ourselves, go into it deeply, and then we uncover things. So we're uncovering things about time by just talking about it, right? And this is a conversation, if you were walking here with me, we could just be talking about, how do we know time exists? And, you know, you could laugh, oh, of course it does. Well, really? I mean, how do you know that time exists? Like, don't laugh at it. Don't, like, really look at that question and say, well, okay, I don't know. You take for granted what people tell for you as being true. And if you do that, you never see truth. And because you don't look into it on your own, and you know, someone tells you something, you believe it, you move on, and then you build your whole life around belief that other people have told you. So this is why I thought time was very important. After the last video that I made earlier, I felt like we hadn't talked enough about it. And we hadn't talked enough about time as state changes. And I think this is so important because you start to see the relativism of time in that perspective. So even a cesium atom, right? And I don't know a whole lot about it, but I'm pretty sure you would have to have it. It would require it being at a certain temperature, right? A certain temperature, which also is a measurement, right? So you have to build devices to measure temperature, and then you have to say, okay, if you have cesium atoms at a particular temperature, they will oscillate at a particular frequency. But if it's not at that exact temperature, it will oscillate at a different frequency, which means time will be different. If you define time in terms of the number of oscillations of cesium atoms, then anything that can affect the frequency of those cesium atoms oscillating then changes time. Right? Then time just becomes dependent on all these other factors. Temperature. So you have to have like a really controlled experiment in order to measure time in that way. And then what that's just showing you is how many things time depends on. But see, we don't look at it, we think there is an absolute time, we just need to set up the experiment to measure it. But if you don't do that, that's an imaginary thing. If every experiment you can set up measures something different, then time is different for every single experiment. It's not the same. Because then time is what you measure by that experiment. And if you set up the experiment up differently, you measure something different. And states may not proceed in the same way. So you can think of like the oscillation, just temperature, right, as being a good factor of tuning the atomic clock based on temperature. If you change the temperature of the cesium atoms, I believe, unless we're talking nuclear here, I guess I don't know. I have to do a little more research. It doesn't matter. Whatever it is, there's something it depends on. There's some factor that may cause a change in that measurement of time to where you can never be certain that you're always measuring time precisely the same exact way all the time. So all you're doing is measuring this. This goes back to what we were saying. Time, the more fundamental thing is the change of state. So the swinging of the pendulum is a change in state. So clocks that depend on that. Winding, the old-fashioned watches that you have to wind, right? You're winding it, that energy, and then it's ticking because there's an unwinding. The coil is the energy source, and then it's causing something to tick at a particular frequency. But if anything is off, right, the metal has to be a certain. This all depends on the properties of the metal, the temperature, how old the watch is. Time will move at a different rate according to that watch if any of those variables change. So, but I think the key thing is to think of it not as, well, there is this absolute time that we're measuring, and we just have to set the experiment up just right to measure it. Or every experiment is simply measuring a different time. And we control the experiment to try to control this definition of time, but it's just important because, and we talked about this in the last video, the value even of a clock is that we believe the states are passing in that clock similarly to like if I want to measure my age, right, again, but we talked about that, biological age. I mean, I would say that if that clock tells me I've aged 20 years, then I think, okay, my body in some way has gone through 20 years of aging according to that clock. But if I kept myself really healthy and I, went jogging and, did other things, that change in state of my body may not be 20 years worth. Right? Or 20 years of aging doesn't mean the same for everybody. And you can say, well, okay, but still 20 years passed, but it's just everybody's body's different. Okay, well then time as experienced by everybody is different. If time is the counting of states, so it's counting the number of pendulum swings, it's counting the number of vibrations of the cesium atom, then time even in your own body can be looked at as the changes in states in your body, which are so complex that you can't measure them all, right? It's much more complex, your body, than a clock or any device. But it still consists of states. But you can't measure it. But, you know, you only think it's because there's this relationship between you and the clock and your perception of time. Right? Because remember, we talked about this too. The mind is perceiving time at a certain rate because of what's happening in the brain. But chemicals can affect that. Sleep or sleep deprivation can affect that. The psychological passage of time. Your experience of time depends very much on the body and the environment that you're in, whether you're sleeping, whether you're awake, whether you're intoxicated or not intoxicated. So your experience of time, and this is why it's important to watch your own experience of time. You know, observe what's happening while you're awake and even while you're asleep, you know, and see how time enters into your body without a clock, right? So if we had no clock, here's the problem. If you're surrounded by anything that changes states, you could consider anything that changes states to be a clock. So the earth spinning is a clock. The earth moving around the sun is a clock. That's how we get seasons. So we measure time by seasons, measure time by days. We can see stars moving in the sky and measure time more accurately by the motion of those stars. So you could say that's another form of a clock. So you could look at a tree and say, are there leaves on the tree? Well, that means it's probably spring, summer. The color of the leaves could tell you that it's fall. If there's no leaves on the tree, it's likely winter. So by observing the state of things around you, you surmise time. But if all that's gone, take it away. Take away the tree, take away the spinning earth, take away the stars, which we can't imagine doing. Take all that away, and it's just you, right? And your perception of your personal time, like the thoughts occurring in your brain, would then be the only indication of time. And then take those thoughts away. And now there's no passage of time at all. And is time still passing? And for you, your experience of time. So this is so important. This is why I didn't intend on making any other video this evening, but I'm like, I just couldn't leave our previous discussion where it was, because I wanted to really make this connection between states, changing of states and time, and what we consider a clock. What is a clock? And understanding that anything can be a clock if it changes states, and how arbitrary our measurement of time can be, and that this concept of time that we hold so dear is really not as firm as we think. And I just want, this is important because time plays such a big role in us identifying ourselves, in who we think we are. So understanding time physically, which is what we're talking about in some sense now, and then understanding the passage of time psychologically, which is our thoughts, and how the thoughts in our mind change and evolve, and that we form this image of ourself through the passage of time, through the changes of state that occur in our brain. And in the same way that there is a state in our brain that gives us this sense of me right now, that took time to get there, but it can be gone, right? If that structure isn't there in the brain, that physical structure that gives you identity weren't there, an undoing of time, right? An unraveling of time. Time is like accumulation. You've accumulated all these memories, and you have become this bundle of memories over time, simply by accumulating all these states in your mind. And it gives us this sense of me, which is also a sense of time. Because you have this idea of you evolving, you improving, you being young and then now you're old. And it's all time, it's all thought. So I just wanted to go into this and give you just a taste of inquiry into time. Go into it yourself. Ask yourself some of these same questions. How do I know what time is? And how would I know what time is without all these clocks? And if the earth wasn't spinning, how would I know time? So imagine the astronauts, again, the astronauts that just went to the moon were in a spaceship floating around, and the only way they knew about the passage of time is through all the electronic equipment they had around them. They didn't have the benefit of the rotation of the earth. So you can get your days and nights totally mixed up without having that as a... And we just think of it as mixed up, but what it's really saying is your sense of time relies so much on you being on this planet Earth and it rotating, that if you were in a spaceship and didn't have access to anything that indicated the passage of time, your sense of time would be totally different. Time may start passing to you. What would a day be anymore? Right? We have circadian rhythms that keep our body, aligned with natural rhythms of day and night. But those would all get out of whack if you took yourself out of this natural environment. And these are real things, real changes that would occur, real physical changes that tell us. What does it tell us? How dependent our perception of time is on the physical form we have, the environment we are in, what we're surrounded by, and that it is a malleable thing. Time is a malleable thing. And we only have this sense of security, this sense of the absolute time, because of the stability of nature. Really, in a lot of ways, it's the stability that nature, every day the sun comes up. Right? What better clock do we have than the sun? And the sun is there every single day. What if the sun wasn't there anymore? I mean, it's a horrible thing to think about, right? But the sun is a star. Won't be there forever. But it's our best clock, right? It's the clock that everything on Earth is synchronized to. The two clocks we have, right? The sun, the rotation of the Earth about its axis, and the rotation of the Earth about the sun to form the seasons. So we have days from the rotation of the Earth. We have seasons from the rotation of the planet around the sun. And that forms those are the two big clocks. It's like the big hand and the little hand, right? The big hand is like the seasons, or the little hand, yeah. Yeah. The little hand and the big hand, the like minutes and seconds on a clock. So you have a slowly moving cycle, which is the seasons, and then you have the daily cycles. And we have oriented our lives, and everything living on this planet has oriented its life around those cycles of time, of natural time. We take this for granted. We really do. We don't understand that our entire perception of time would be different if we didn't have that. If we didn't have the Earth rotating, and we didn't have the sun, the stars, like that, all of that has constructed this concept of time that we have. And it sounds like the rantings of a lunatic, right? I think about what someone would say if they come around the corner and heard me, and they could very well be true. But I think question this, right? Question it, go into it, and don't take it for granted, and don't just wanted to sit here and look at the sunset. Speaking of the sun. And then also think of the beauty of time. Right, here's another day is gone. Another day has come, and I went for a walk. I mean, we did a bunch of things. Right, a day has come, a day has gone, and that is, we measure time by that. Another day of our life has come and gone, and here we are. And things are happening. I'm hearing what sounds like fireworks in the distance, probably because of the Memorial Day holiday. And people are celebrating, but there's so much more to it, right? And I could talk for hours. I could keep talking, but me talking isn't really helping you. It's helping me, because in just this process of discussing it, it's like my own brain is understanding this better, in a sense, more clearly. And I think that's why I wanted to articulate this in another video, because I just wanted to just say more about it, but it seems like there's never enough words, right? So all I can say is look into time for yourself and your experience of time. Watch your mind and how it perceives time, and all the clues that you have around you that gives you a sense of time, and how that's related to your thinking, and how your thinking perceives time, and how without thinking, time would be perceived differently. So how intimately thought and time are connected, are related to each other. In some way, they're almost the same. So I guess that's what I wanted to say. I don't want to say too much more right now, but I think I just wanted to not just leave it there, and now just enjoy the sunset. All right, well, it's time to say goodbye. All right, bye.